Okay, I'm going to go over worksheet 15-1 about mean absolute deviation. You need to grade it with a marker or a colored pen. Make corrections to the one that you miss, and I'll give you some credit as long as you are correcting them and showing all the work that I show on here. So keep up with the number that you miss, like you're actually grading it. So you'll put that number up at the top before you turn it in. Okay, it says find the mean absolute deviation for each data set. The number of kittens in 10 litters. So the first step of getting the mean absolute deviation is to find the mean. So I had to add all this up and divide it by 10, and the average, or the mean, was 6.6. You had to use that number and go back and subtract each data piece from it to get all of the deviations. So you need to check and correct your deviations if it wasn't right. The first one is 2.6, 1.6, 1.6, 0.6, 0.6, 0.4, 1.4, 1.4, 1.4, and the last one was a 2.4. The last step is to add all these deviations up. Remember, they always have to be positive, and then divide by 10 again. So that one gets me a mean absolute deviation 1.4. Number 2, the number of approved soy-based containers produced in a 10 stamping runs 240 containers. So again, first step is to get the average. For this problem, your average is 231.4. You have to go and subtract everything to get your deviations that are all positive. Check the ones that you got: 6.4, 4.4, 4.4, 3.4, 1.4, 1.4, 0.4, 6.6, 6.6, and 8.6. Last step is to get the average of your deviations. So I had to add up all these positive numbers and divide by 10 again to get the mean absolute deviation on number 2 is 4.4. Number 3, 2 bowlers bowl the following number of strikes in 9 games. What is the mean and the mean absolute deviation of the number of strikes of each bowler? Okay, for the first bowler, the average was a repeater. It was 6.2 repeating, but you had to round it just to 6.2 because you don't want to go and do the subtraction part with a repeater. So all your deviations for the first one right here, you need to check 1.8, 1.2, 1.2, 0.2, 1.8, 0.8, 2.2, 0.8, 0.2. Then you had to average those positive deviations. So the MAD of the first bowler was another repeater, 1.13 repeating, but if you just rounded it to like 1.1, that's good. The average for the second bowler is another repeater. This time it was 7.2 repeating. If you rounded it to 7.2. The deviations that you got whenever you went to go subtract were 2.8, 1.2, 0.8, 0.8, 2.2, 2.2, 1.2, 0.8, and 1.8. You had to go and average those positive deviations to get a MAD for the second bowler. It was 1.53 repeating, but if you rounded it to 1.5, that's good. What does the mean absolute deviation suggest about each bowler's consistency? Okay, so if I'm comparing these two MADs, I notice that this one's smaller because it just has a 1.1 compared to over here was a 1.5. So the smaller the MAD means that it deviated less from the average. So bowler number 1 had a more consistent number of strikes per game. The last problem says a charcoal producer needs to make sure that his manufacturing process on average does not use more than 1 ton more or less of the average amount of biomass in order to make the most efficient use of his equipment, labor, time, and other resources. The table lists the number of tons of biomass used per day over a 10-day period. So this problem never said what is the mean absolute deviation. So you have to be able to read it and look for keywords that are telling you to go find that. So I would underline that it talks about the average of an average. That's what the mean does. We had to find the average twice. And we're going to go ahead and underline the goal that we do not want to use more than 1 ton more or less. So basically my MAD, they did not want it to be more than 1. So first, of course, you know that you have to find the average. For this problem, it works out to be 14.3. I'm going to go get all the deviations, how far all of the data pieces are from this average. They all had to be positive. 0.7, 2.3, 0.3, 0.3, 1.3, 0.7, 2.7, 3.7, 2.3, and a 1.3. And then I had to get the average of the deviations was 1.56. If you rounded it to the 10th, it didn't tell you to, but you would have got 1.6. But it didn't just want us to stop there. Number 4 says, are the results of this 10-day production run within the limits the producer wants? Use the mean absolute deviation to support your answer. So I'm going to say no, the MAD is greater than 1. At the top we underline right here that they did not want to use more than 1 ton more or less. So this MAD tells us that they were not within the limits that the producer wanted. That's why we had to put no. So count however many you missed. Each one is separate from each other. Even like the mean and the MAD are separate problems here. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. So out of 9, put how many you missed at the top. I will get your grade because I'm going to look to see how many you corrected. You'll get points for those. Turn it into the bin and watch the next video.